Okay, in this series of videos, I'm going to go over every problem in the unit for review. I'm breaking it up into a couple different videos. If I did, it'd be too long. So number one, use the graphs below to answer the questions. Which of the lines has a positive slope? So I'm wanting you to look at and see the shape of a line can tell you something about the slope. So positive slopes go uphill. That would be this line, which would be B. Which one has a negative slope, so it would be going downhill, which would be D. Which has a slope of 0, which means horizontal, and that would be C. Which leaves the undefined is a vertical, and that would be A. Okay, number 2, is the data in the table linear? Does it make a line? If so, give the rate of change, tell what it means, and write an equation. If it is not, explain why not. So to tell if it's linear, we need to look at whether the change is the same from point to point. So I'm going to look from 43 to 37, what happens? Well, this drops 6 degrees, right, temperature. So it drops 6, so negative 6. From 37 to 28, it drops 9 degrees. Right away, I'm like, uh-oh, those aren't the same. But we're not done because slope is not just the change in y. It's also the change in x. We'll do that in a little bit. From 28 to 13 is down 15. But now we have to go over and do the same thing for x. So from point 1 to point 2, 2 hours passed. So 2 hours passed. That's positive 2. So 1 plus 2 is 3. From the second point to the third point, 3 hours passed, right? And from the third point to the fourth point, 5 hours passed. All right. Now to find the slope between each of these points, I need to set up y over x. So negative 6 over 2. Okay? So it dropped 6 degrees after 2 hours passed. From the second to the third point, it dropped 9 degrees, but 3 hours passed. And then from the third to the fourth, it dropped 15 degrees, but 5 hours passed. So now I just got to reduce each of those, and I see that they're all negative 3. So is the data linear? Yes, it is. The reason we know that is the slope is the same for every single point. The slope is the same or constant, which makes it a line. Okay? The rate of change of the slope we just found was negative 3. What does it mean in this problem? And I've kind of said it multiple times, but it's how much the temperature drops per hour. So it's how much the temp drops per hour. And now it says write the equation. So we've got the slope, it's negative 3. I've got 4 points here. Y equals mx plus b. I'm going to choose one of the points. It really doesn't matter. I'll just take 337. Again, that's completely random. If you chose a different one, it wouldn't matter. And I'm going to plug those numbers in. This is x, and this is y. So 37 goes in for y. Slope is negative 3. X is positive 3 plus b, and we're looking for the y-intercept here. So 37 equals negative 9 plus b. Now I'm just going to add 9 to both sides, and I get 46 for b. So now my equation is y equals mx plus b, so y equals negative 3x plus 46. And just interpret one more thing. What was the temperature when they began to measure? So when they began to measure, no hours had passed. 0 hours had passed. So if I put 0 in for this, I'm going to get the y-intercept of 46. So it's 46 degrees. Okay, number 3, write the equation of the line with a slope of 2/3 that goes to the point negative 3, 5. Write your equation in slope-intercept form. Okay? So we kind of just did that here. So y equals mx plus b. I'm going to put slope of 2/3 in for m. X was negative 3. Y was 5. And we're looking for the y-intercept. Okay, so if I'm writing my answer over here, I know I could already write 2/3 x. I just have to find what goes at the end. And that's what we're doing here. So 2 times negative 3 is negative 6. Negative 6 divided by 3, that's negative 2. Now I'm going to add 2 to both sides, and I'm going to get b equals 7. And now I can just put plus 7, and there's my equation of the line. Okay. 4 through 7, it's all finding slope. So that equation that we're using is y2 minus y1 over x2 minus x1. Just make sure you're using the right numbers. I'm still seeing a lot of people mess that up. So y2 is the second y value, which is 3 minus the first y value of negative 3. So 3 minus negative 3. I'm not going to even fix that yet. Then it's the x's, so 6 minus negative 2. Okay? And now just do the math. 3 minus negative 3 is like 3 plus 3, which is 6. 6 minus negative 2 is like 6 plus 2, which is 8. And then I always want to reduce. And I get 3/4. So the slope on this problem is 3/4. Okay. Number 5, same thing. So 8 minus 4. And then negative 1 minus negative 1. So 8 minus 4 is 4. Negative 1 minus negative 1 would be negative 1 plus 1, which is 0. When 0 is on the bottom, our slope is undefined. If 0 were on the top, the slope would be 0. Okay, the slope of the line 4x minus 3y equals 24. So again, I'm just asking you to find slope. But in this case, instead of giving you 2 points, I'm giving you the actual line. To do that, I need to get this into y equals mx plus b, which is subtracting 4x to negative 3y equals negative 4x plus 24. Then I divide everything by negative 3, and I get y equals, a negative divided by negative is a positive. 4/3 cannot be reduced, so it's 4/3 x minus 8. 24 divided by negative 3 is negative 8. That really doesn't matter because all I want is the slope, which is this, in this problem is 4 over 3. Number 7, I want the slope of the line perpendicular to y equals 2/5 x minus 4. Well, the slope of that line is 2/5. The slope of the perpendicular line, you gotta remember how the perpendicular slopes are related. They're opposite reciprocals. So if this is positive 2/5, this one's got to be negative. One's positive, one's negative. That has to be the case. And then you flip the fraction. So instead of 2 over 5, it's 5 over 2. So the slope that I want is negative 5 over 2. Okay. Continuing on. For 8, 9, and 10, it says find the y-intercept. If it's in slope-intercept form, that should be really easy. This one's in slope-intercept form. Y is by itself. Y equals 4/3 x. What's being added over here? Nothing. The number that represents nothing is 0. No work needed. I can just look at that one and see the y-intercept. Number 9, that's a weird form. We haven't seen that one. Okay? I need to get y by itself, just like I said over here. I need to add 12. But I can't add 12 because of the parentheses here, so I need to get rid of the parentheses. I do that by distributing. So y minus 12 equals 2/5 times x, which is 2/5 x. 2 times negative 10 is negative 20. Negative 20 divided by 5 is negative 4. Now I can add 12 to both sides. And I get, let's do it here, y equals 2/5 x. Negative 4 plus 12 is plus 8. The y-intercept is 8. Okay? Now, number 10, you could do 2 different ways. I could do what I did back here on number, sorry, I'm going to be flipping a little bit here. I could do what I did on number 6 and get y by itself, and that would give me the y-intercept. Okay? Or you could see that it's in standard form. To find the y-intercept, okay, that means x equals 0, right? Which means I could put 0 in for x. So 7 times 0 minus 5y equals 70. Well, 0 is going to cancel that whole thing. So basically that's all going to be gone, and I'm going to be left with negative 5y equals 70. And now I just divide by negative 5, which is going to give me the y-intercept of negative 14. So there's my y-intercept. Okay. For 11 and 12, write the equation in standard form using integers, then tell what the x-intercept is for each equation. First, I'm going to look at this part. The form that's going to help me the most when I'm trying to find the x-intercept is standard form. It's in slope-intercept form, finding the x-intercept is not easy. The y-intercept is, but the x-intercept is not. Standard form is what's easier to find my x-intercept, which is why I'm having you write the equation in standard form. Okay? Using integers, which means no fractions. So let's clear the fraction right away. I'm going to multiply by 6. That's going to get rid of that 6 there. That's going to give me negative 5x. Negative 5x. But I can't just multiply one thing by 6. I got to multiply everything by 6. So it's going to be 6y equals negative 5x plus 60. But now x and y have to be on the same side, so I need to add 5x to both sides. So I'm going to get 5x plus 6y equals 60. Now to find the x-intercept, I put 0 in for y. But just like up here, when I put 0 in for something, it's going to cancel that whole thing. So when I put 0 in for y, that whole thing's going to go away, and I'm going to get 5x equals 60. I'm going to divide by 5, and I'm going to get the x-intercept is 12, which is the point 12, 0. Okay? Over here, kind of the same idea. The fractions with the y this time doesn't really matter. We're still going to multiply by the denominator, which is 2 in this case. So I'm going to get 6x equals negative 5y minus 18. I'm going to add 5y to both sides. So I'm going to get 6x plus 5y equals negative 18. The x-intercept, put 0 in here. I'm going to get 6x equals negative 18. Divide by 6. But the x-intercept is negative 3, which is the point negative 3, 0. Okay. I'm going to graph now the next 6 problems, and that's going to be the end of video 1. There are multiple different types of graphing that we've done. The first one was in slope-intercept form. This one's in slope-intercept form. The y-intercept is 6. That's where I'm going to start. I'm going to go up to 6 on the y-axis and put a point there. Now from there, I'm going to go down 4, right 7. That negative can only go on either the top or the bottom, not both. I'm going to put it on top here. Down 4. That makes 7 positive. So down 4, right 7. To get my second point, and now I'm just going to draw my line. Okay. Number 14, y equals 5. By the way, I'm going to write this out actually so you can see it. Slope is negative 4 sevenths, y-intercept is 6. Slope is what? Y-intercept is what? There's no x here. The only way that x is gone is if the slope, the number in front of x, is 0. The y-intercept is what's left. It's 5. So I'm going to go up to 5, put a dot, and now I'm going to go up 0 over 1. So up 0 over 1, up 0 over 1. Y equals 5 is a horizontal line. 15 doesn't look like anything we've seen, except for maybe a number 9 at the top here. I want to get y by itself, so I'm going to distribute the 3/4. So I'm going to get y plus 3 equals 3/4 x. 3 times 8, 24. Divided by 4 is 6. Now I'm going to subtract 3 from both sides, and I get y equals 3/4 x plus 3. Now I can find the slope, which is 3/4, and the y-intercept, which is 3. So 1, 2, 3. Up 3, right 4. And there's my line. Okay. Number 16. This is in standard form. I'm going to do this problem using the x and y-intercept just so you can see it. You don't have to do it this way. You could solve it for y just like we did here. But I'm going to do the x-intercept, put 0 in for y. I get 12x equals 48. Divide by 12, I get x equals 4, which is the point 4, 0, which is on the graph right here. The y-intercept, you put 0 in for y, or sorry, for x. And then you get negative 8y. Don't forget that negative. equals 48. Divide by negative 8, you get y equals negative 6, which is the point 0, negative 6. And there's my point, and there's my line. Okay, notice how that went there, and that went there. Connect, there's my line. Okay, 2 more for this video. It's these 2. Now I'm not doing intercepts on this one on purpose, because when I do the X-intercept, I'm going to get 15 over 8. That's not a good number. And it's really hard to plot a number that's not good. So I'm going to get this one in slope-intercept form by subtracting 8x. So I get 5y equals negative 8x plus 15. Divide everything by 5. Negative 8 divided by 5, I can't reduce that, so I'm just going to leave it as negative 8 over 5x. 15 divided by 5 is 3. So I'm going to go up to 3, and then I'm going to go down 8, right 5. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 2 points. There's my line. Last one, another one of those weird ones. I'm going to get y by itself by distributing negative 4. So y minus 5 equals negative 4x. Negative 4 times 3 is negative 12. Add 5. So y equals negative 4x. Negative 12 plus 5 is negative 7. Negative 7 is right here on the y-axis. Down 4, right 1, right? Well, I can't do that. Down 4 doesn't work. Let's move the negative to the bottom, so it's going to be 4 over negative 1. Same slope, just putting the negative on the bottom instead of the top. So I'm going to go up 4, left 1. And there's my line. And you should see that if I would have gone down 4, right 1, I would have ended up on the line anyway. Okay, and that gets us through video 1. Next video is going to cover writing equations of lines.